control them from here.
But I can do it from here.
Yeah.
I'll do it. Carsten is like it's not working.
I can control them. I present this one, so the other one.
No, I mean the other one.
The other one, you are Carsten.
And Carsten says that his network is not reliable, so I'll just do it over here.
Drive it from your meeting. Yeah. Yeah, I don't have any control for this site. I don't take any control after this site.
Yeah. Okay, so how would you want to
You take it. Let's start. Okay? Let's start. We start, okay? No. Okay, we can start the meeting. Welcome everyone to the session of the core working group at IETF 114. I'm Marco Tirolca, my co-chairs are Jaime Jimenez and Karsten Bormann. And of course, we assume people in the audience to have read the documents in the agenda today. We make good use of our time to discuss open issues and progress the work in the working group. Blue sheets are collected automatically. Please, if you attend on site, in fact, access the meeting through Meet Echo on the live version. The chairs will take care of looking at the chat. We have Ivo and Matthias that volunteered to take minutes. Thank you very much. Anyone is welcome to help them. And Christian, thanks. This is an official IETF meeting, so as usual, the not well applies. We've been recorded, and this is not just about IPR patents and so on, it's also and especially about our code of conduct, so be nice and professional with each other. Also for the participants on site, please ensure to keep the mask on all the time, also when you go to the floor mic to give a comment, ask a question, and so on. Thanks. Yeah, a few practicalities. Again, keep in mind to join through the on-site tool of Meet Echo for the on-site participants. If you want to go to the mic to ask a question, please join the queue first on Meet Echo Lite, then go onto the mic, and then leave the queue when you come back to your seat. Okay, this is the agenda for today. It's pretty packed, so please do your best to stay on time, and the chairs will guide you through about that. We start with the two related documents, href and Coral. Then we cover two documents related to group communication as group comfort co-op as such, and multicast notifications. Then we have two documents related to OSCORE, the profiling of it for OSCORE, and the key update for OSCORE. Then we have a number of non-working group documents, meaning DNS over co-op, performance measurement, and co-op over GATT for BLE. Does anyone have any comment or want to bash this agenda in any sense? Karsten.
Yeah, I just wanted to point out, if we do have time at the end, we could briefly talk about something that came up during the ANIMA meeting on Monday, the CoAP S plus JPY UI scheme. Let's see if we have time for that.
Okay, would 5 minutes work in the end from the flex time?
I think so.
Let's try that. Thanks. Okay, so let's get into the working group and documents status updates from the chairs. So since the Vienna meeting in March, we actually had 3 documents published as RFC. So many congratulations to the co-authors, the working group, and everyone that helped out with that. They are in order, I think strictly in chronological order of publication. The resource directory was indeed an achievement, 92176. SendML data CT in 9193. And Young Seabor, one of the 4 CoreConf cluster documents, now RFC 9254. Congratulations again, Carsten.
Yeah, so I think the 2 of you weren't there when this work was started, at least on the resource directory and on Yang Seabor. So maybe I should just quickly remember people what this was about. Excuse me, I need to reconfigure my audio. That should work better. So the resource directory was started in 2011 from a contribution by Zach Shelby out of the EU project that I already forget the name for, but that actually created the company Sensinode. And yeah, it took us a while to finish this. And 9254 was started in 2013 by Peter Wendelstock. And then Bert van Grevenbosch came and added RESTConf for that, because Peter really wanted to do this with SNMP at first. Then there were discussions whether we would need to start a new working group for this. Then we had the discussions about whether to do hashing to create the identifiers. And at some point, Michel Veillet and Alex Pilov joined and came up with something they called Cool. So, some of the people in the room are a member of a Telegram list called Cool. That's the origin of that Telegram list. Yeah, so we got lots of help from Andy Bierman and Jürgen Schönwalder. We invented the differential coding. Then we had several submissions in 2016 that explained the best way to register these SIDs would be using blockchain. Michel actually wrote code for PYang to support the SIDs. And in April 2016, we actually adopted the draft. And then Yang 1.1 was published, so our basis actually changed and we had to react to that. And yeah, it took another 4 years until we finally made it to Working Group Last Call in 2020. And then we had the pandemic disruption, so it took us to July to have a second Working Group Last Call, February 2021 to have an IETF last call. And then we had to uncouple the drafts to get at least one to advance. And in April, Yang Seabor was approved, and now it was just a little bit of Auth 48 before we finally got it published in July. So just as a reminder how these things work. So if you want to congratulate anyone, do congratulate Peter and all the other people who made this stuff happen. It's been a long time.
Thanks a lot. Yeah, and by the way, I noticed you're co-author of all these 3 RFCs, Carsten, so well, I think you played a major role indeed, in many senses. Okay, moving forward with the update. We also have another document not published yet, right now in the document queue, in the RFC editors queue, and this is indeed an achievement considering what has happened in the last few months following the Vienna meeting, during which the document was still dormant and then was resurrected in April for a rush to completing it due to the urgency in 3GPP. And the result was great, I think. Thanks again to all those who contributed that too. And then in ISG processing, we have another of the CoreConf cluster documents, CoreSeed. There was a resubmission earlier today of version 19 following discussions among the co-authors 180. Carsten wants to say something.
Yeah, just this document is officially out of the hands of the working group, but the feedback we got from the ISG was pretty substantial. So there will be substantial changes to the document, and it's important that the working group actually pays attention to this. So formally, this will probably take the form of second IETF last call, but that's for the ISG to decide. I don't know that. But yeah, please follow the GitHub repository, which, by the way, is the Yang Siba repository for historical reasons. And there are 2 pull requests in there right now. One is mainly editorial, but it's a long pull request. And the other one is very short, but it's technical. And we want to merge these 2 pull requests and get feedback on this -19 and submit a -20 to finally lift the discuss that is open here.
Thank you. Yeah, we have also a number of documents in post-working group plus call, meaning the other 2 core documents, Komai and Yang library, that just have to wait for course state to be completed before being brought up on Surface to work on them. And then we have the group score document, which is currently in Shepherd write-up. We also wanted to mention other documents that are not in the agenda for today. There are 2 that have been recently adopted, attacks on co-op and transport indication, for which there was also a recent resubmission with little updates with the version 1. And then we have another one, pending working group adoption, group.com proxy. Karsten, if it's fine for you, you can take this one.
Yeah, now if I were remembering what this was about. Sorry.
It was presented again at an interim meeting in May, basically requesting for adoption.
Yeah,
so
and we
up to the church.
Yeah, we made a resolution there, and I probably should repeat that resolution here, but I must admit I don't remember what that was. Too many balls in the air, I'm sorry.
Well, trying to remember the minutes were made, that there seemed to be interest and energy to work on it, but then it was up to the chairs to consider a call for adoption that, yeah, since then hasn't started.
Okay, so maybe you can say something at the end of the meeting, so I refresh my memory.
Sure.
I'm sorry.
All right. And we have a few more individual documents around. There are 4 that have been resubmitted with some updates, meaning restoring cacheability of OSCORE protected responses, using OSCORE also with proxies possible with multiple layer of protections, extensions for the resource directory, and everything on co-op as kitchen sink. We also have around 2 new submissions. Core parameterized content format was presented at the recent interim meeting also. And then a new co-op option for early data usage of TLS or DTLS 1.3, equivalent to the corresponding HTTP header, basically. So we encourage you to read through these documents that couldn't make it for today's agenda. Okay, that concludes the introductive part, and we can actually start with 1 minute of advantage with the first actual item on the agenda, href, and that's Karsten.
Okay, so this is mainly a report. We don't really have time to discuss this, and I think this is really the stuff of which interim meetings are made. So just as a reminder, CRIs are concise resource identifiers. They are the concise equivalent of URIs and URI references. And essentially what we did is we looked at URIs, extracted the generic data model that URIs have, and made a structured representation of that. So the current status of this is there hasn't been an update of the draft because we are essentially done. We are finding occasional little nits that we have to fix. But most of the work at the moment is on test vectors and implementation. So we want to make sure that our various implementations actually work with the URI implementations that we find on our platforms. And it turns out if you want to do something that uses the entire envelope of the URI data model, you are fighting with your platform. And that's something that we have found out. So we have much less of a problem with actually doing the CRI part, but doing the URI part in the bidirectional translation. So there have been 2 PRs lately, which are on GitHub, but not yet in the internet draft. A short lamentation about percent encoded text, because that really is a syntactic feature of URIs and doesn't fit at all to the semantic structure of CRIs. So they are best avoided, but if you want to be able to write a translator that works for any URI, you have to include that. And the other observation was that we forgot to put in a rule to prefix a relative URI by // if the first path segment in the relative URI contains a colon, because that colon will look like the whole thing starts with a scheme. So you have to prefix that with // to make sure it's recognized as a relative URI. So that's on GitHub. Already, what is on GitHub as an issue right now is the question, what do we do with the URI foo colon? So the URI foo colon could be a URI for the scheme foo that does not have an authority, but has 0 or more path segments. So it could be foo colon /bar /bez. But we have 0 of these segments. So in this case, the representation would be the scheme foo and a null, and the null can be taken away. So it really is just an array with a scheme. So this fits with what you actually see. But it also could be foo colon opaque something, like a Meitu URL, Meitu URI. And that actually would have exactly the same URI syntax, but a different CRI representation. So we need to decide which of these 2 we don't support. And this presenter is leaning to say we support the 0 segment path-based URI, but not the 0 length opaque URI. And one reason for that is that I have never seen a 0 length opaque URI, and I don't know how to do the proper research to actually verify that. But I think it's relatively unlikely that somebody just wants to use a URI scheme and nothing after that, but allow opaque stuff after that as well. So that's the decision where we could flip a coin, probably because the practical effect will be minimal, but for consistency, I would go for number 1. So if anybody in the audience has ever seen such URI and has an opinion on that, please send email to the list or speak up now so we can get some help in making that decision.
Sorry, Carsten, there's a comment from Brendan on the chat. Are these URIs or URLs?
Hi, Brendan Moran here. Since the question's coming up at the mic,
yeah.
I figured I might as well do it myself.
Yeah.
The slides thus far, I haven't been able to tell whether we're discussing URLs, URIs, including URNs, or something else entirely. I can see one obviously is a URL. That one's clear. 2 looks to me a lot like URN, but you're calling it opaque stuff, and URNs are not opaque. So I'd like to be absolutely clear whether things like URNs are in scope here.
Okay, the terminology in this space is completely confusing. So there is IETF terminology and there is WG terminology, and what we call URIs are called URLs in WG and in other daily vernacular. So please excuse if I'm not always clarifying this very well. But all this is about URIs. So CRIs are supposed to cover URIs and actually IRIs as well. Because
but not URNs.
Well, URIs is the overall term that includes URLs and even URNs.
Okay,
now,
so CRIs are supposed to produce, like, I don't know what you would call it, a CRN?
Well, they're all CRIs, and actually a URN, and that's another problem. There is URI scheme called URN, and half of the people who say URN mean a URI that uses the scheme URN, and the other half means the foo colon opaque stuff that is number 2 on this slide. And for URN, of course, opaque stuff is the registry and all that structure behind that. But it's not a hierarchical URI like what is number 1 on my slide, which is, by the way, not a URL because it doesn't have an authority. So it's
fair
something
enough. Yeah.
different again. So that's really not helping very much to try to use these terms. You best think about URIs with certain specific properties, like having an authority, having a segmented path, and all that.
Yeah. Okay. Thank you.
Good. I have 2 minutes left, so please send things to the list that you think about these things. Let me just quickly talk about curries. We talked extensively about curries at an interim 6 weeks ago, and I just want to report from that. Essentially, curries are an opportunity. It's not something that we need to do, but when we do this, we might as well make sure that we handle curries. Curries are a way to do some lexical compression of URIs that also looks good on a whiteboard. So it's used by a lot of formats that need to look good on a whiteboard. And curries are a compression scheme that is based on URI syntax. So there is no relationship between curries and the structure of a URI. You can just cut up a URI anywhere and put the different parts into different places that amount to a curry. So that was really hard to support. The mechanism that would best support this is CBOR Pact, and CBOR Pact now has function tags that can be used for reconstructing a URI out of a curry. So we are kind of in a position to do this now, even though it's way more complicated than the other things that CBOR Pact does for us. But in the interim I talked about, we decided to do this in a separate specification, and we didn't quite decide whether this needs to be done in Corel or in a separate document. We still can do that. We need to start writing that document, and we need to start which of the potential curries we actually support. So 2 of the ones on this slide are in strikeout font because they are probably not easy to support, while the other 4 probably are. So let's talk about that. But the point is that whatever we come up here and define as a better curry or a concise, compact CRI or whatever, doesn't have to cover the entire curry space. So in summary, the plan is to complete the test vector and implementation work, decide the foo thing, and do the working group last call with the next version of this document, and in parallel start work on a CRI query kind of thing that would fit into CBOR Pact framework and would fit together semantically with what we have done on the CRI side. And now we have 0 minutes for discussion, I think.
Thank you very much. Just a question, when do you expect the next submission, more or less?
That depends a bit on how many other bugs we find in our implementations. But we are down to a small number now. So I would think this is not months, but weeks.
Okay. Great. Looking forward. Any last quick question for Karsten? Anyone? No, thanks again, Karsten. And next item is Coral, presented by Christian.
Hello. So this is the next part coming from, we now have CRIs. Now that we have a way of expressing URIs well in a compact and embedded friendly way, we can use this to build structured documents that talk about resources. For today, I'd like to pick up a few of the open issues and ongoing things that are around in Coral. For that, I'll briefly, for everyone who is not familiar with Coral so far, I'll just summarize very quickly. This is a way of making statements about resources similar to 6690, but with the extended options to have real structured data in there, to build larger trees of data, and to better guide interactions by using forms. Properties that are relevant for today are that this is in its structure similar to our, in the information model that is behind it, similar to RDF. So we have statements that link one resource or one URI through some predicate that is also expressed in a URI with an object that is either another URI or a literal. If you look at this example statement, my temperature resource supports the series transfer pattern. You'll see that in so neither of these is what it looks like in CBOR, obviously, but this is a more of a diagnostic notation here, and you'll see that often here in the slides I'll be using the very queries that Karsten just talked about, because the full URIs behind those are lengthy. But if it says core colon here, this probably means something like http://iana.org/registry/ something that leads into core. A few things were changed recently, and one of those is that literals are now much simpler. So if you've been to the interims, there has been discussion on what identity means if literals can still have properties. The current direction in which Coral is going, and this is already part of the latest draft, is that we do not need properties on literals, because we can use we can use the expressiveness of CBOR text. So for example, in earlier versions of Coral, a lot of a typical metadatum on a literal was the language or the text direction. This is now all covered in CBOR text, thanks to also thanks to Karsten for covering that inside problem details, because this is now where the relevant CBOR tag that we'll be using is defined. What is still ongoing? What is also ongoing and is in part of the current document, but not in full, is how we use CBOR Pact now in order to express all of these statements clearly, so concisely. So what you see here is an example translated from the proposal on the PubSub broker, and everything that is a query here in this diagnostic notation would in a binary representation be expressed through CBOR Pact. Now this is a part that's already in the document. It says we're using CBOR packed and no custom mechanism anymore. Frankly, I think that CBOR packed was from a not very old idea, reuptaken partially because it is really useful here. What is not yet in the document but being planned for the next update is how we do set up this dictionary. So some of those statements would probably would ideally be loaded with a document type. So when you receive a Coral document, then there's already a dictionary set up that says that we can use all these core terms. So the title statement could be in CBOR diagnostic notation, could be as in the second line here, and have the whole HTTP iana.org/something/core/title compressed down into those 2 bytes of a CBOR packed tag. Extending this to cover a larger variety of subtype of problem spaces this can be applied to is not quite trivial, because if we only set up one dictionary, then this would mean that we have to register every term in that dictionary. And the plan that I'd like to go with here is to allow setting up additional dictionaries using a mechanism very similar to what is already in CBOR packed, by stating that we are loading a particular number of terms from a well-known additional dictionary. This means that we don't have to lug around the weight of those. If I said dictionary earlier, my apologies, I meant tables. Terminology has changed here. That means that we don't have to lug around the weight of having those tables. We don't have to let our numbers grow incredibly large, because we have so many entries in the table, but we can use them selectively, and by utilizing well-known tables, we can also express this selection concisely, as is shown here in the 5th line, again using just a few bytes to select that table, that set of tables. If an application really goes outside of the scope of what is known to be around core, then they can still load those by identifiers named through a URI. Another item that is actively being worked on is the security model. Coral will definitely need we need to say something about security, but we plan not to kind of redo things that are already described in security models such as ACE. But what Coral will provide is, for application authors, a way of expressing what the application needs from the Coral agent, think of this like a browser, to enforce. And for the Coral agent, there will be rules that say how those statements from the application are applied, and what they mean in the context of loading, for example, a document with a dictionary that is externally referenced. Because in essence, every piece of information that goes into assembling an action from a document will depend, and security-wise depend, on the integrity of all the resources that go into making that statement. So these are the areas that are being worked on. Next steps that will be taken up is that the binary serialization will need to be revisited. But in order to do that, and this is part of what I'm asking the work group for input, is that in order to evaluate that, we'll need real-world examples. So whatever you would like to use this with, please let us know. Please send example documents that we can then translate, and based on that decide what good choices for the serialization will be. Problem details is something that will go in here. A non-next step, in a sense, is the topic of queries, patches, and provenance. As much as I'd like to have those around at some point, I don't think that these are good items for the first version. So I think while we should keep them in mind, I wouldn't want to have them around in an initial version because I think it would slow things down too much. And I think I'm just on time to ask for the working group for comments and questions and for whether this is the direction that we should follow before time's running out. Thank you.
Thank you, Christian. Any comment, question, anyone? Not in the chat, no one in the queue. I have a question just to be sure I understand correctly. So I suppose in the short term, you want to focus mostly on the items you had in slides 6 and 7, while possibly working in parallel, but at a slower pace on the items on slide 8, correct?
Yes, 6 and 7 are ongoing items, and items in slide 8 are being started and are held back by the lack of examples. But both will be addressed in parallel.
Sounds great. Thanks. Still no one in the queue, nothing in the chat. Okay. We can move to the next one. Yeah, it's great if you control that. Thanks. Okay, this is Marco. I'm presenting as an individual. This is an update of the group combis document. Next slide, please. Okay, thanks. So in Vienna, we presented version 6, and after that, the document entered working group last call. We received quite a lot of comments, all very useful. Thank you very much. Most of them were from reviews from Karsten. Well, a summary of the review was actually posted on the list, but then the authors got a lot of detailed comments to address, in fact. There were also more replies from John Shallow, basically concurring with Karsten and pointing also to libcoop as an implementation that also supports group communication. Ricard confirming that the document is good. And John Matson started a PR on the GitHub, so far only with editorial fixes that we already adopted in the latest version, but I'm aware that more comments are coming there. Next slide, please. So for the cutoff, we submitted the latest version 7 to the best of our knowledge. It is addressing all the received working group call comments. I'll just summarize the main updates here. We have revised and extended the list of updates or actions that this document produces on other documents, especially the obsolescence of 7390 and the update of 7252. We also had a figure providing an example of how you can combine the different types of groups, meaning co-op application and security groups. We were just requested to build a real-life storyline around that examples, and we did that considering a building automation use case to make it felt more real. Next slide, please. Yeah, there was quite a lot of work to do also on improving content related to the naming of the different group types. And as to co-op groups, we highlighted also with examples that it is possible to name a co-op group in different ways, playing around with an aliasing based on the subcomponents of the authority component of the group URI. And then we used to have a lot of examples in the document body showing how you can name in different ways application groups and how you can discover groups of different types actually at the origin server. So we moved all those examples with the necessary editorial adjustments out of the document body and to appendices. And that, I think, improves readability quite a lot. Also, as to security groups, we clarify that, well, yes, they have names as invariant identifiers, but they're not exactly used in the protocol defined in this document or in the actual co-op group messages exchanged. They are useful in other protocol and mechanisms defined in other documents, especially in ACE, as supporting security for group communication. And since we had the opportunity, we also clarify that it's a bad idea to use nosec or its variants, lowercase, uppercase, as a name of a security group, because, well, it'll be very misleading if it's an actual security group, while if you use the nosec mode without security, that's just no security group at all to name. Next slide, please. Thanks. And more was done also on proxies. This was also mostly from comments from Karsten. We better clarified the limitations and issues that you have in general if you introduce a proxy in this kind of setup, and again that they are possible to address by using the method in the group.com proxy document that, by the way, defines also how you can deal with these issues where you consider specifically an HTTP to co-op proxy. We also clarify a bit of terminology related to this, and we also describe what happens in the case where the co-op client sends a group request, for instance, over IP multicast to be received by multiple proxies at once, each of which in turn forwards the request to the group observer, discussing separately the case with and without security. It was also noted by Karsten that we were a bit too strict in saying that group communication cannot happen with reliable transport, where multicast cannot happen, but we were already discussing a case when using blockwise, where a first group request can be sent over multicast with the block queue option, and then the following requests to request the following blocks from the origin servers can be sent individually via unicast to each of those servers. And well, those unicast requests can in principle use reliable transports. And this kind of transport switching within the transfer of the same body can also be facilitated by means of the work in the core transport indication document. And there was also a revision about the interworking with other protocols, especially related to multicast routing and referring to most recent IETF documents, especially in 6.0. Next slide, please. Finally, to wrap up on the updates, we revised again the phrasing around the use of the no-sec mode, trying to be uniform and assertive all over the document. The no-sec mode where no security is used is highly discouraged. It's not recommended. There are a few exceptions mentioned up front, like early discovery of devices or services before you can do anything better. So you basically, you have no other choice. But still, even so, you need to have very well understood the security implications of this. Editorially, we are also using that without quotes now, just like RFC 7252 does. And we have also revised the number of security considerations related to properties of group of score, possible fragmentation issues in 6.1, and pervasive monitoring, especially highlighting how that makes a difference in group communication. Plus, of course, an overall editorial revision of the whole document. Thanks. Yeah, to wrap up, this last version addresses all the comments we got so far, but we expect at least one more version to be submitted because we expect a follow-up from Karsten with counter comments on how we addressed his review. And yeah, I know that John will follow up also with more comments on his PR, and who knows, maybe more can come. But yeah, we expect at least one more version, and hopefully that can be a final one, really incorporating all comments in a stable way. And finally, I just wanted to give a reminder that Francesca at some point recommended that when it is ready, this document would be better sent to the ISG together with other two related documents at the same time. One is group of score, now in Shepherd write-up. Another one is a document in ACE describing how to provide keys for group of score. And actually, that line in the slide is not correct anymore. I've just found out that a few hours ago, the document moved to waiting for Shepherd write-up. That doesn't change the fact that I was expecting a few more comments coming to address, and I have also in the queue some more points to add in this very document and in another related one. But I discussed this part already also with Daniel, and his co-chair. He definitely agrees with the need of thinking about a single bundle to be submitted to the ISG. So this is the status, and that was my last slide. Any question, comment? Christian?
Christian, I'm just, I was a bit wondering when you mentioned that the way that second and later blocks are pulled out, that those happen with unicast. I suppose this is based on the statement in 7959 that says that this is how it works. Was there any evaluation on whether getting the later blocks with a multicast as well, so just a get with the block 2 option, would make sense, because the 7959 says that other uses of block options with multicast are for further study, and now that the group communication is revised, this might be a good point.
Yes, and to clarify, the switch to unicast for the following blocks was already in the draft for a while. What Carsten noted was that, well, at that point, the switch can also include switching to a reliable transport altogether.
I see.
Thank you. Okay, if there's nothing more, now with that, we should expect the next version. Thank you. The next one is Christian again with observe multicast notifications.
You're muted, Christian.
Just trying to find the right buttons. So we stay with the topic of multicast. And so original co-op, as well as the updates that were presented right now, only describes how multicast packets are used to send requests, and responses that are sent to many clients were so far not described. This is what Observe Multicast Notification does. It allows sending responses to a group of clients whose token space is managed by the server as a steward of that multicast address. This was envisioned as part of discussions around the PubSub model, which is why the illustration here shows this as a broker fanning out the responses, but is really applicable to all kinds of observation situations in which a large number of devices in a network that support multicast well is observing a single resource. As with all modern multicast components, this is supported by GroupOS core in order to get actual cryptographic protection of requested responses, or responses mainly here. Since this was last presented at the last session, we've made a few updates. In particular, we are now elaborating on how a client can obtain the necessary configuration information. That is, what is the precise request, on which token was it sent, at which multicast address, from which multicast to which multicast address is the response being sent, etc. That the client can not only obtain these from trying to set up an observation, but also through other means, because in a sense, it is just a piece of information about a state of the server that is around. A typical way of obtaining that information is because it is part of a PubSub discovery step. The current document also not only describes that this is possible, but also what this means for the server, because if the server is not handing out that information on a short-term basis, but as a general statement, that means that it must have the request already running and must be sending out multicast notifications for as long as that information is around, which still doesn't free it from looking at whether it is necessary to still send these notifications, but it has to keep track. It has to keep track of both the number of participants and whether it has that statement still in a valid form somewhere around. A few updates were just editorial, being that terminology was adjusted or changed, but there were also conceptual new input, or at least, yeah, there was a lot of new text. For example, all those prerequisites that are listed in the introduction that are we have to have a multicast address that is managed, and we have to be on a network, etc., are now listed explicitly. This also takes input from reviews that we've received on some prerequisites where we were previously a bit sloppy about describing them. Another new section, also based on input from previous reviews, now lists the various modes in which this can be used, because we do have a lot of examples, and the document was previously a bit confusing as to which configuration is now being used. So for example, if there is group OSCORE being used, if there are deterministic requests being used, all these change subtle details of what this means for the precise packets that are being exchanged. A current point that we would like to change in a future version is the handling of deterministic requests, because so far we haven't been fully clear on what it means for a deterministic client to be in a group with respect to whether clients are required to implement deterministic requests. The proposal now, previously this meant that a server could need to run both two notifications, one with a deterministic request and one with a regular request created by the server itself. The proposal now is to just say that given that already there's so much pre-configuration required for this all anyway, that it makes sense to just state that the group has or has no support for deterministic requests, and if there are deterministic requests being used, then the clients have to support these, and the server doesn't have to run two parallel observations for the different kinds of clients. This should be a reasonable simplification. Another change that is coming up, and this is already part of a draft branch, but not yet ready to be merged, is that we have a lot of information in the phantom requests and in the informative responses that relate to addresses of co-op endpoints. And given that now CRIs are becoming stable enough to reuse them in this document, we are slowly switching all these occurrences over to just using CRIs. So instead of using our own list of what protocols are around that support multicast, we just use the schemes that are part of the CRI, that are registered as part of CRI, and those that can do multicast are usable in this place. This is also aligned with work on proxies that has a similar field that previously listed both a protocol and an IP address, and now just lists the CRI. And so in practice, this means that just a number of fields are renamed, and that information moves a bit between fields that are now grouped together or are split up from what used to be one field. Yeah, that being said, we've also processed a review from Ayana, some of which does not fully apply anymore because it is related to how we previously defined those transports, which is now using CRIs, or which will now be using CRIs. But the rest of the review is still very valuable and will be part of the next iteration. I think that's largely it from me, and I think I've made a bit time. So thanks for your attention. And do you have questions, comments?
Thank you. Anyone for a common question?
Hi, Christian. One question. How do you think this draft could affect the existing PubSub draft and the PubSub work in general? Major modifications, minor? What do you think?
It does not. I don't think that this will influence PubSub in any way. In that a PubSub broker can still be set up as it always was. It just has an additional option of using this feature and using it through a lot of places. So it would advertise additional information about the resource, but the basic PubSub would not change, and this is purely opt-in for applications. So it just meshes well.
Okay, more questions, comments? None. Thank you again.
Yeah.
We're perfectly back on time. So now it's Ricard's turn with 2 documents in a row, starting with profiling ad hoc for co-op and score.
Yes, let me share the slides. Just have to find it in the list. Okay. Right. So yes, hello everyone. I will be presenting updates on this draft profiling ad hoc for co-op and score. And I'll jump right in. So just to go over a recap about what this document is about. So first of all, ad hoc, that is a lightweight authenticated key exchange being developed in the Lake working group. And one of its main usage is to establish a score security context between 2 peers. Typically, when you run ad hoc, though, you need 2 round trips before you can actually start using OS Core. And the point and the scope of this document is the main focus is how can you achieve an optimization where you actually combine the third ad hoc message with your actual first OS Core request, as you can see in the blue box there to the right. So it's essentially defining an optimized workflow for ad hoc when transported over co-op with the intent to use it for OS Core. And it defines some OS Core specific processing of ad hoc messages. And it also extends this ad hoc application profile that has a number of, let's say, configuration settings related to the ad hoc execution to take place. And in the document, we also define parameters related to web linking for discovery of ad hoc resources and their application profiles. So overall, the scope is ad hoc transported over co-op. And the main item here again is this optimized workflow to reduce the actual amount of round trips before you can start using OS Core communication. And yeah, to go over some of the updates then, since IETF 113. Some of these things were presented already at the core interim during April. And the updates now in these slides are because of changes that happened in the ad hoc draft, which is now in version 15, right? So the first point is that there's no more special conversion of identifiers needed. Instead, there's a simple identity relation where before you needed a more elaborate way to convert from OS Core to ad hoc identifiers, which is now no longer needed because of the changes in ad hoc. So that could be simplified. And another point that was changed is that the text and examples now reflect usage of the new content formats. So you have this application SID ad hoc plus CBOR-SEC and application ad hoc plus CBOR-SEC. But the actual combined ad hoc plus OS Core request still has an unnamed media type. Some other things, small changes, updating of the terminology, ad hoc applicability statement was renamed to the ad hoc application profile. More things, just some rephrasing here, changing a must not to should not based on feedback during the core interim. That was in relation to let's call good behavior expected from the client. Otherwise, the processing of ad hoc messages was revised and simplified. When it comes to how you select your own ad hoc connection identifier, which then is practically offered as the OSCOR, your own OSCOR recipient ID that you will receive for the OSCOR communication. Also, consistency checks on incoming ad hoc messages was revised, and things are now also consistent with requirements from section 3.3 of RFC 8613. To continue on the updates, the consistency and the text about ad hoc application profiles templates was simplified. Again, no need to say anything about this OSCOR ad hoc identifier conversion. Before, there were parameters in there about like which conversion method you want to use. That's no longer needed. And then it's about signaling, like if you support the ad hoc plus OSCOR request, the application profile should signal that support, and you then cannot signal to use an ad hoc message for, because you cannot, it's not compatible to use an ad hoc message for together with this optimization. The web linking part was also revised, removing the target attribute related to the conversion of identifiers, and also admitting multiple instances of EAD target attribute to support basically, because you have can you have an EAD in each of the ad hoc messages, right? So you can have an EAD 1, EAD 2, EAD 3, etc., depending on which ad hoc message you're talking about. Some security considerations were added, like you could, for instance, this flooding attack, if you want to flood the server with ad hoc plus OSCOR combined request, that's actually not a security problem, because the server does not process the same ad hoc message tree multiple times, and the server performs replay checks on those OSCOR protected application requests. So this kind of flooding will not give you any practical attack. Then we had some considerations on blockwise. So the question is, when can the ad hoc plus OSCOR request get too big because of ad hoc, so that essentially you're forced to use blockwise? Well, one such occasion is if you have a very large ID to ADI, like a big certificate chain, or if you have large items in the EAD, in EAD3 specifically, like just a big amount of data there. Then we covered basically client processing to say that, well, to clarify that only the first inner block actually conveys ad hoc data and the ad hoc option. And if this ad hoc plus OSCOR request exceeds the max unfragmented size, you should stop. And this max unfragmented size is a parameter defined in the OSCOR RFC to provide particular attacks, like for instance, a proxy injecting blocks in the middle of a blockwise exchange. So that's for security reasons that should be obeyed. Also server processing, that's just as the RFC 7959 and 8613. We have new section 6 guidelines on not using blockwise or using blockwise together with the ad hoc plus OSCOR request. So when should you use it? So the client might use inner blockwise, but in this section we assume that it's actually not using outer blockwise, because typically a client wouldn't take the initiative to use outer blockwise. That would be something a proxy does. So it's possible to fragment the application data you wish to send, but not the actual whole ad hoc plus OSCOR request. Continuing on, more about the blockwise and optimized workflow. So basically, there's a limit here, which is the practical maximum size to exceed before you should use blockwise. So there's a lot of logic here to follow and considerations on what you should do. But basically, depending on certain parameters, it may or may not be okay to send OSCOR plus ad hoc request. So if the ad hoc data is below this limit, then if blockwise is not used, then that means the application data plus the ad hoc data is below the limit. And if blockwise is used, that's when one block plus the ad hoc data is below the limit. So I'm a bit low on time, so I probably don't have time to go into details and all these considerations, but check that section in the draft and it goes into a lot more details on these aspects. There's also some corner cases and kind of trade-offs when you actually you end up having to use blockwise just because of the ad hoc plus OSCO request, just because the fact that you're combining that into a single request. And we concluded basically that the optimized workflow can be no worse than the original one, but it could also be basically that in this case, in some cases, you should actually not consider using the ad hoc plus OSCO request if using it means that you end up having such a big request that you're forced to use blockwise. But again, check the section in the draft for more considerations on this. Going into some next steps, well, we want to add more security considerations. So about when you should use the ad hoc plus OSCO combined request and relation to access control enforcement. And we do have running code on this based on Eclipse Californium and aligned with ad hoc version 15. Of course, implementing ad hoc and this optimization. To do is to renew this order registration we did of the ad hoc option, and the ad hoc option signals usage of this optimized request. And if there are no big issues, we do feel that the next version may indeed be good for a working group last call. And it may here be good to sync with the leg working group and basically take it in parallel with the working group last call of ad hoc. That makes sense because these documents are very much interconnected. And again, yeah, any comments or reviews are very welcome on this document. Thank you.
Thank you, Richard. We are slightly over time. There may be time for one question or comment, maybe. Anyone?
I see Christian saying, yeah.
Karsten, go ahead.
Yeah, I just wanted to make the point that we have to be a little bit careful about not stuffing our specifications with too much informational content. There are many reasons why we don't want to do that. One is that we are essentially DOSing IESG. But also people who look at this specification and see, oh my God, that's 28 pages. Do I have to implement all that? Might think this is a complicated document to implement. And actually, it's not very complicated. So I'm wondering whether we have a good way to put things like these considerations. Is it actually an improvement to use this or not into the separate place, so we can clearly separate the standards track part, which actually is relatively simple, from the how do I use this in the best way possible informational content. So I'm not saying that this draft is the one where we absolutely have to do this now, but it struck me as just another example where we are getting into this trap of providing too much informational content, or where we may be getting into this trap of providing too much informational content. So I just wanted to set this flag here that we should be thinking about that. I don't want a response right now, but when you work on this document, think about is there maybe something that could be exported into an informational document meaningfully, so the actual specification stays crisp.
Okay, I see what you're saying, right? So to consider that we don't have a too wide scope and too much content, possibly some things could be extracted to a different document, or I don't know, the appendix as an appendix or something.
Yeah, appendix is certainly one way. The informational documents cause about 1/3 of the ISG overhead of a standards track document. So putting stuff into an informational document is an effective way of both reducing the appearance of this being a complicated document. Moving things into the appendix, if you label it as non-normative, then maybe some reviewers won't read it, which may be also another way to reduce the load. But still, when the people first look at the document, they see this has 28 pages, and they won't see that only 10 of those are in the body and 18 are in the appendix. So actually splitting documents may be something that we may want to do a little bit more than we have been doing. And by the way, once you have an informational document, this can also be used as a little bit of a roadmap. So you explain how the normative documents that are being created here actually fit together. And it can be on a different timeline. So there are many benefits that can be had from this, but also, of course, it makes the management of those documents a little bit more complicated during creating them.
I see, but thanks for the feedback. Yeah. And I saw, by the way, Christian had a point also agreeing on syncing with Lake as a comment in the chat. Yeah.
Yeah, about that, just to be sure to understand, Christian, you would prefer this document to follow up after ad hoc, right?
I think I could only make a reasonable working group last call document on this document if ad hoc is also in around working group last call stage.
Okay, one possibility was to have them in parallel working group last call, in fact. But your comment sounded like you'd prefer to have them strictly one first and then the
No,
other.
it doesn't have to be strictly in sequence. Maybe my comment was phrased sloppily. Just parallel would be great.
In sync. Thanks. Okay, in the interest of time, let's just continue with the next slide set.
Yes, indeed. I'll change text then. Yes, I'll proceed right away. So now I will continue on this draft key update for OSCORE, which we named Kudos as a short title. And yeah, so again, just a kind of a content recap and an overview of this document. So it essentially has two main parts. One part is about a way that has been defined to provide a lightweight way to perform key update for OSCORE. And that's what we call Kudos. And this is loosely inspired in the Appendix B2 procedure already defined for OSCORE, where the goal is essentially to renew your master secret and master salt, which in turn makes you derive new sender and recipient keys. And this procedure can also achieve perfect forward secrecy. And there can be various reasons why you would like to rekey, but one particular reason that this draft covers is that you may reach limits in how many times you have used your keys for encryption or decryption. Because there's actually work going on in C4G where they have determined and defined some usage limits for AED algorithms. So essentially, you need to follow certain rules on how many times you encrypt or how many times you fail a decryption with your keys before you have to rekey. And if you do not rekey and have this excessive use of the same key, it can enable breaking the security properties of some AED algorithms. So the second part is about these limits. But the focus on today will be the Kudos part and the key update procedure. The limits part has not had any major updates recently. So again, an overview of this key update procedure is basically a message exchange. You have a client and server. Let's say the client is the initiator. You exchange a number of messages, as you see on the right-hand side. The key thing here is you want to actually exchange nonces. And using those nonces, you want to derive new OSCORE security contexts on both pairs using the nonces as input. And we define this update CTX function basically that takes the nonces and the old security context and produces a new security context. We also extended the OSCORE option so to have a bit that indicates the presence of this nonce parameter and an X byte that signifies both the length of the nonce, but also some additional signaling flags, which I will come back to later. And we got some comments from Ayana about if in particular, like notes on the language, if this bit 1 and 15 can be 1 suggested and 15 suggested, but we do actually need and prefer exactly 1 and 15. And by the way, this nonce was previously called ID detail. We now simply just call it nonce. So that field in the Oscar option is simply called nonce now. And yeah, now I'll go over some of the updates that we've done practically to the draft since the last meeting. And one thing we did here is we defined, or rather revised and moved text about an alternative kudos mode that does not provide forward secrecy to the main body of the draft. So the whole idea here is that you need a way to do stateless key updates, because some devices may not be able to store information to persistent memory, and the method, the main method of kudos, the main mode we have defined, really requires that you're able to store information to retrieve it back after you have rebooted. And if you cannot do that, you couldn't use that main mode. So because of that, we defined this mode that doesn't have forward secrecy. But then the benefit is that it's stateless, and these devices that cannot store to persistent memory can still use it. And well, there's then the need for a way to signal this, and the way we define that is we defined a bit P that we placed in this X byte in the Oscar option. So again, the X byte signifies the length of the nonce and some signaling bits. And well, a P0, the sender indicates that it wants to run kudos in the forward secrecy mode, the normal original mode. If you set P to 1, you wish to use the no FS mode. And basically, both pairs need to agree here, so that both need to set P to 0 or P to 1 in their respective request or response to align and agree to use a particular mode. And if they don't agree, there's a possibility for a negotiation to downgrade to the capability of the device that has the least capability, so that you can still agree and actually be able to run kudos. And when you're using the forward secrecy mode, basically your security context that you use to drive a new security context is just the latest security context that you have stored. And it's also a key point here that if you are capable of storing to disk, and if you're capable to use the forward secrecy mode, you must use that mode. The no FS mode is just as a fallback if you absolutely cannot use that, or if the other pair cannot use the FS mode. So when you're using the no FS mode, yeah, again, you sacrifice for secrecy because one pair cannot write to persistent memory. And the difference here is that before you run kudos, the key material you consider isn't your latest key material. You consider your bootstrap key material, which is what you were pre-provisioned with during manufacturing or commissioning or recommissioning. So that's like a fixed key material that you have stored down, and you can still remember that, even though not being able to write to persistent memory, since that's something hard-coded on you as a device. So again, this is agreed downgrading. If the initiator sets P to 0, the responder may not be able to follow up on that because it cannot actually use the FS mode. In such case, the server can respond with an error response, setting P to 1 to indicate, no, I want to use the no FS mode. Or if it's a client that's a responder, you send a request with P to 1. But essentially, you use this P bit to signal to each other and agree on which mode to use. But if both devices are capable of using the forward secrecy mode, they must do so. Continuing on. So another thing we moved up was the text about preserving observations. So this was also text in an appendix. And basically, we identified the problem here that there is this risk of but basically this is a scenario. A client can start an observation 1, by sending a request with the request partial IV X. After that, the peers run kudos, reset their gender sequence numbers back to 0. And later, while this observation 1 is still ongoing, the client will send a new request 2, also with request partial IV X. And the problem here is that basically you have 2 kind of ongoing in progress requests with the same partial IV, and this gives you a problem that responses or notifications by the server will cryptographically match both request 1 and request 2. So what you need to be careful about basically is that do not reuse the same partial IV, right? Because like the thing is, after you run kudos, you reset your partial IV back to 0. So you cannot reuse the same partial IV that you already are using for an ongoing observation. And to solve this, we devised this long jumping solution. And essentially what that means is that after kudos has been run, you jump your partial IV forward to the value of the highest rec PIV among all going observations where you are a client plus 1. So it's just jump over the highest partial IV that's already in use for an observation to avoid this accidental partial IV reusage. That is basically that. I mean, that's of course if you wish to preserve observations. So to be able to signal if you wish to preserve observations, we defined one more bit, which is this B bit. Again, it's in the X byte of dot corruption, and if the B bit is set to 0, you're saying that you're wishing to cancel all common observations. If the B bit is set to 1, you wish to keep all common observations. And this is an all or nothing approach. Both pairs have to agree and set the bit to 1 to decide to keep them. If one or both of the pairs set the bit to 0, the observations will not be kept. And again, it's a key point here. You cannot just, if you wish to keep observations, you cannot just like silently forget observations. You must explicitly use cancellation requests and only purge observations if you get a cancellation confirmation from the server. Because otherwise, if you just forget observations, you may again run into this problem of accidentally using a partial IV that is in use for an observation on the server side. And one thing that was pointed out here is that if 2 pairs actually don't want to run kudos for sake of key update, they may wish to use kudos just for a way to quickly cancel all ongoing observations with the other pair. So another part was about the updating of sender recipient IDs. This was basically triggered by some discussion on the mailing list and an issue in the OSCOR draft GitHub, OSCOR RFC GitHub repo, basically. And the intent is that due to privacy reasons, you may actually want to switch identifiers, for instance, just after having run ad hoc, to prevent, like if you switch network, for instance, you may not want to be that an attacker can correlate your identity through this ID between the old and new network you switch to. And yeah, this procedure can be run standalone or part of a kudos execution. This has also been moved up from appendix to the main body, and it has a number of properties here. Basically, we defined a new option where you indicate your new desired recipient ID, and that's a class E option, so it's also encrypted using OSCOR then. And there are some considerations on when you should use this and when you should not use this, and some things you should be careful about in terms of remembering all the used recipient IDs. Some more updates. Well, this is kind of going over the signaling bits, right? So we define now the signaling bits are placed in this X byte. So we have the 4 least significant bits that define the length of the nonce, -1. We have the no forward secrecy P bit, and then we have the preserve observations B bit. And with 2 of the bits still reserved. And I mean, one point here was to place these bits in the X byte. And then what we did is we defined the update CTX function to take not only the nonce, but the X bytes also as input. So because these are now involved in the key iteration, they end up being integrity protected, which is a very nice property. And for the actual update CTX, basically there's two like internal paths it can take. One is if your original context was derived using ad hoc, use the ad hoc key update to derive your new context with the nonce as input and the X byte as input. The other method is, let's say you didn't use ad hoc at all, well, then you use a simple HKDF expand to derive the key information for the new context. So this kind of allows you to use the nice ad hoc key update if that's available to you. But if you didn't use ad hoc, you're still good to go and can use the other method. When using method 1, we have now aligned the text so it's up to date with ad hoc key update, which takes CBOR byte string as input basically. And we also define some rules on when you can like overwrite your PRK out and PRK exporter keys, which are keys ad hoc keys that you use for deriving the final key material, master secret, and master salt. So this is a bit more details on the update CTX. Basically, we needed to kind of define a way to handle the X values and the nonces. So here in this figure, X1 and X2 are the raw values of the X bytes, and N1 and N2 are the raw values of the nonces. So we have this like way of blending X and N values into just standalone X and N parameters. So you can see here in the case of message 1, X is simply X1 and N is N1. But in message 2, you have a bit more complicated construction. You have a wrapping, CBOR wrapping of X1 as a byte string, concatenated with CBOR wrapping of X2 as a byte string. That's X, and N is constructed in a similar way. I mean, the point is that we want to do this wrapping because we want to maintain and keep the length information about the nonces in the concatenation. So there's no risk of this kind of attack where you just have two concatenated byte, raw byte arrays where possibly an attacker could try to splice to do some attack where like the concatenation ends up being the same. So in other contexts, it was pointed out that it's important to keep the length, and their CBOR is very useful because it has the length in the header, right? And then we actually invoke the update CTX with these XN values. And within update CTX, we do some more wrapping because one key property we want to achieve here is that ad hoc key update should be taking a CBOR byte string as input. And we got some feedback on this from Karsten with some suggestions, but that's really the reason we designed it like this. We want ad hoc key update to take a CBOR byte string as input because that's how it's designed in the ad hoc draft. Yep, open points. I'll go through this a bit quick. So we have a number of issues on the GitHub repo. We'll go through those and fix and take care of those. We have a proposal here to split up the CTX into two actual separate functions because, like I said, it basically has two internal methods. Method 1 relying on ad hoc and method 2 relying on an HKDF-based approach. And we also want to have a signaling way so you can signal to use the method 2, because what if your context was defined and derived using ad hoc, but for some reason your ad hoc session is not around anymore, so you cannot use ad hoc key update practically. Well, then in that case, you would like to fall back to the HKDF way, and we need some signaling for that. And one easy way to signal is just add one more bit in the X byte to be able to signal this. And we also want to produce an implementation of this based on those core Java California implementation we already have. And of course, yeah, comments, feedback, very welcome. Anything you have to mention. Yes, thank you.
Thank you, Christian.
If fallback to this method 2 is something that can just be started by one party, does the mechanism lose any relevant properties? Because if it doesn't, why do method 1 after all?
Well, we would like to, I'm not sure if I fully got it, but we would like to use method 1 if possible. If you can use ad hoc key update, we would like to take advantage of that if possible. And I would say that the signaling on the fallback, that signaling could be done by either party, because it could be that the initiator has its ad hoc session still and wants to use method 1, but the responder can't, or it could be the opposite. So both have to, it has to be kind of a mutual bidirectional signaling, and both have to agree to be able to use method 1, because if one can't use method 1, they both have to fall back to method 2.
But is anything valuable? What is actually lost when falling back?
You basically think like what is the
which properties does
yeah,
this lose any valuable properties?
Comparing method 2 to method 1. Yeah, that's a good question. So you're saying it basically like they have the key update and the HKDF based way, they're just as secure. They may have the same security properties regardless. That's your point, as if I understand it correctly.
Yeah, that's the question. Yes.
That's the question. Yeah, that's a good point. If there is a concrete a security property that method 1 has that method 2 does not have, I cannot answer that right now without thinking more about it. Yeah.
Just the last point from Göran, then
yes.
Just to go offline in the interest of time. Sorry.
Yeah, Göran Selander. I'm just thinking about, I mean, in the spirit of Karsten's comment here on size of drafts, is it possible to split out some parts in separate drafts? I was thinking about it changing recipient IDs. Could that be a separate draft? Or update. Okay.
I mean, I would say it could, because practically, I mean, this is a standalone procedure. You can run this standalone without kudos, but you can also run it embedded in a kudos execution. So it could be, if that could be a way to go. I mean, yes, to split this out into a separate document, it would be that would be feasible.
And what about the key limits and the kudos protocol?
I mean, yeah, I mean, I think I would say same story there fundamentally. They could practically be, you could have one draft that's about kudos and one that is about the limits relating to OSCORE. That could be like that for sure. I think it grew out like this due to earlier discussions and feedback. It ended up being these were joined in the same document, and they are relevant in the sense that, okay, one reason to do key update is because reaching the limits, but fundamentally, if the desire is to have a like more but smaller drafts, yes, I believe it could be split. Yes.
Okay, thank you.
Thank you, Richard, and all for
you.
the comments. We will need to move on. We're 12 minutes late. Please follow up presenters. Try to save 1 or 2 minutes, if not more, of your presentation. Thank you. Hi, Martine.
Martina, you're muted, I think.
Sorry, can you hear me now?
Yes.
Great. Okay, I try to make it quick air then. Yeah, I want to talk about DNS over co-op. I give a quick introduction for those who weren't here the last few meetings, then give you the changes since the last interim I attended, and then go a little bit into some discussions around DNS push and co-op observe, which came up after we pushed the current release, the current version of the draft. Basically we want to save DNS requests from IoT devices against eavesdroppers. So the typical solution for that is to encrypt the name resolution. And our proposal for that, since other approaches don't work in the IoT scenarios we are looking at, is to use DNS over co-op, which is able to encrypt the communication either via DTLS or OSCORE. And we also have additional advantages like clockwise message transfer to overcome passing DU problems, which we encounter, for example, with DNS over DTLS. And we can also share system resources with co-op, since we can use the same socket and buffers, and also reuse the co-op retransmission mechanism. Since last interim and last draft version I presented here, we made basically some changes to reduce restatements on co-op behavior. Among other things, we try to be more precise when a confirmable con message should be used. We cleaned up our paragraph on error behavior. We removed the blockwise recommendations completely because they basically just restated what co-op blockwise RFC is telling you about. We removed the sentence that states that fetch is sent to server URI, and we removed the considerations on proxies. On caching, especially, we provided an algorithm to synchronize up the co-op max age and DNS TTL so that not some timed out DNS records are lying around in some co-op cache somewhere. And we removed the ETAG considerations since that also just restated co-op behavior. Then we did some to-be-dones. We recommended OSCOR usage and basically just stated, okay, use OSCOR if you want to use DNS over co-op, but you don't have to. And we drafted out already the observe usage, but as I already said in the beginning, this still needs some work. And we removed the to-be-dones on issue 4, which was about having some repetitions in the DNS format, which we want to, at some point, put into a separate draft for a compressed content format, which probably will be CBOR based. And yeah, and left to be done, maybe we can discuss this here also, is the YANA consideration, where we didn't pick an ID for the application DNS message content format yet. The main reason is because there are probably with DNS some nice numbers we want to use, and I wanted to maybe discuss this first. And so after all that, I go into the DNS push and how to implement this with co-op observe. So first, a brief primer on how DNS push notifications work according to RFC 8765. They are based on DNS stateful operations and are basically very orthogonal to the query response paradigm. So you send the DSO stateful operation with a subscribe message encapsulated for a certain record you want to query. That then is for that then you get basically a subscribe ACK, and then the recursive resolver can start to push also with DSO messages if there is an update to a record. And also you can unsubscribe via a DSO option. So the problem with that is that with that the RC 8765 basically just states that we require DNS over TLS for that, and there's basically a must to that, and we also need additional state information. So to not soften this requirement and also to make the implementation on the client side simpler is to use rather use co-op observe as a signal to use subscribe instead of a query at the doc server, which would look a little bit like this. So we have just a normal fetch with a normal DNS query encapsulated and an observe option that the doc server takes to do the subscribe that we saw before. And then when there is a push, the observe response basically also comes, and there's an observe notification. Oh, there's a little error, but I leave that to the reader. And for unsubscribe, we just do also a normal unsubscribe with fetch, or like when there's coming a reset back from the doc client. So as an example, there could be, I put that on the mailing list. Maybe some comments there could also be given. Basically, I brought out how DNS service discovery could work when using doc. And basically, you would just ask for a pointer for all co-op services in a network, and then get a response back. And this would be then a push. And if there are new services joining, this list would be just updated. So yeah, that's basically it for my part, at least what I drafted out. So if there are any questions or comments, you're welcome to give them now.
Thank you, Martina. Any comment, question, anyone? None in the queue, in the chat, in the room. So yeah, this draft has been received pretty well so far, especially the previous IETF meeting with also a few people supporting the work and committing to review. So the chairs believe that the obvious next step is starting a call for adoption on this. Is there any comment on this, any objection? Then we'll start an adoption call on the mailing list.
Okay.
Thank you very much, Martina.
Yeah, thank you.
Also for saving time.
Great.
There's a comment. On the chat, Carson disagreed.
Okay. Next presentation is Giuseppe, performance measurement for co-op.
Hello, everybody. Can you hear me?
Yes, we can hear and see you. Hi.
Okay. Hello. I will share the slide.
It's the second from top, second left, second from left icon on top to request sharing the slides.
Yeah. No, sorry.
Yes, and if you can please speak a bit closer to the mic.
Okay. Okay, I guess you can see the slide now. So, okay, let's start. Yeah, this is an update about the co-op performance measurement option. So this is the 0.2 version. And I'm presenting on behalf of the co-authors. So yeah, just a few words about the motivation. This is not the first time that we presented this work at CORE. So we also presented at the interim meeting in March. So the motivation is to find a mechanism to measure the performance in co-op to meet the operational requirements. And of course, since we are talking about constrained environment, we need a simplified, simple mechanism for network diagnostic. Since it is resource consuming to read ID, sequence numbers, store timestamps for constrained nodes, of course, the methodology needs to be straightforward and simple to be implemented. Regarding the changes from the 0.1 version, it's important to clarify that most of the changes are to add the comments and input received during the last interim meeting from Carsten, Christian, and Marco. In particular, I want to highlight the main points and the main changes we apply to the latest version. So first of all, we clarified that the co-op option is, of course, selective, safe to forward, and it's not to be included in the cache key. So then we specified the detailed scenarios and the use cases. In particular, we described the use of non-proxying endpoints or the application in case of collaborating proxies or non-collaborating proxies, and also we described the application in case of OSCORE. Then we also included a new section on management and configuration aspects, even if these aspects are not fully in scope of our draft. And then we also improved the security considerations part by adding the new consideration on the TLS and OSCORE as well. The methodologies that are used by the option that is introduced in this draft are not new methodologies, but they are already defined in IPPM working group. There is a draft in working group last call that is called explicit flow measurement. And these techniques employ few marking bits inside the header of the packet for loss and delay measurement. In particular, there is the spin bit idea to create the square wave signal using a bit. The length of this square wave signal is equal to RTT, and it is optional in the quick specification. While the square bit creates square waves of very no length, so for example 64 packets, and this can be used for packet loss measurement. So these are the two basic mechanisms that are also defined in IPPM. So the goal of this draft is to apply these methodologies to a new co-op option. I cannot see the slide. Okay. A new co-op option carrying these performance measurement bits. In particular, the draft defines two different patterns. If we use the square bit or the spin bit together, or if we use a sort of combined square bit, which reinforce the square bit with also delay information in order to measure everything with just one bit. And we also extend the possibility to have the option with also other event bits that can be used for signaling the proxy or the gateway that maybe do not have the capability to apply the algorithm for spin bit, and square bit can read these event bits to understand the different levels of thresholds and so on for delay and loss. Okay, now I want to describe, of course, the addition, one of the main additions that we did in the latest version about the details of the application scenarios and use cases. So the main usage of this option is for end-to-end measurement, but split measurement are also allowed. And this is an important point because the intermediaries and non-path observer can do the measurement as well. And they can be a network function on probes that can act as an on-path observer, or gateway or proxies that are tasked by co-op client to perform a request on their behalf. As I said, there are different cases: the non-proxying endpoints, the collaborating or non-collaborating proxies, and the OSCORE. In case of non-proxying endpoints, the co-op option can be applied end-to-end between client and server. Since it is elective, it can be simply ignored by an endpoint that is not configured to handle this option. The enabled measurements are end-to-end, of course, between client-server, on-path, both upstream and downstream on the observer, and also intra-domain, because if you have more than one observer that can be the borders of a domain, they can also do the measurement between two observers. So you can have a sort of intra-domain on-path measurement. All these measurements are defined in the IPPM draft, so are not new, let's say, for this for this option, for this environment. Then we have a scenario with collaborating or non-collaborating proxies. In this case, the option can be applied end-to-end between client and server, or also between proxies. So if clients and server are not configured to make the measurement, maybe the proxies can do, and they can apply the option. And in particular, in case of non-collaborating proxy, since this option is safe to forward, it is, of course, it is safe for forwarding by these proxies. The enabled measurements can be also can be different depending on the case of collaborating proxy or non-collaborating proxies. In case of collaborating proxies, of course, the measurement can be end-to-end and on-path and intra-domain, as the case of non-proxying endpoints. While in case of non-collaborating proxy, they can also be end-to-end and on-path and intra-domain, but cannot be between proxies. And also the proxy cannot act as an on-path observer. The final case is the application with OSCOR. In this case, of course, if the co-op option is sent as an outer option, it allows both end-to-end and on-path measurement. Otherwise, only end-to-end can be allowed. Yeah, final slide. So yeah, this draft, as I also mentioned before, is based on these methodologies that are also optional in the quick specification and also in another RFC that is also applied to IPv6. So it aims to meet the limited resources of constrained environment since the mechanisms are quite simple. So we believe that at some point, maybe core working group can consider to adopt this work for performance measurement. But of course, for now, we welcome questions, comments, and also cooperation on this work. So thank you.
Thank you, Giuseppe. Unfortunately, there is not much time for discussion. Just please pay attention to the comments in the chat from Karsten and Christian. Yeah, I also wanted to add a high-level comment. I was reading the draft. I still have quite a hard time in navigating the many alternatives that are possible to use, the way you can combine them, and which limitations possibly or drawbacks you have depending on which combination you go for. So I think especially the central sections of the draft should be revised to highlight the limitations of the different alternatives presented in a very systematic way. But to further help, I plan to send out a review to the list after the summer break of this document, where I will also raise these points. Yeah,
I will try my best. Consider that regarding the limitation, there is the draft in IPPM that I reference, and in that draft there are a lot of description of all the possible measurement and also the limitation. So maybe I can add more reference so the reader can go to the IPPM draft if you want to go deep to to understand the limitation and the trade-offs of different solutions. I will improve on that. Thank you for the input.
Okay, again, I'll come back with a review anyway. And yeah, I encourage folks to read the document and also comment on the list.
Quick question, what is the target status of this document? Is this going to be a standard or the informational document or an experimental document?
I guess for now it is a standard because we are asking for a new option. So I guess it should be standard, but if we want to, I don't know what is the procedure for defining a new option in core.
But you just register one. So this could be a registration that you make. We have a space for expert review. So I'm not saying that this is what we should do. I'm just saying that's the gamut of potential outcomes that we have. And an experimental protocol, for instance, would also be a possible outcome. So I think we should have a discussion on the list. Because for me, if you look at the chat, there's also the question of how much of this is an interoperability requirement and how much is just informational content about how you best use this. So let's have that discussion on the list.
Of course. Okay. Thank you.
Thanks a lot. So let's move to the next and last item, Christian. Yeah, take your time, of course. It's great if you can spare some minutes in the interest of the final wrap-up.
Okay, so what I'd like to present here is how we could transport co-op over GATT, and I will digress at the end a bit into the transport indication draft, which is not really on the agenda for today, but it is something that interacts a lot with this document. Now, the original design for transport for CoAP over GATT, which is CoAP over the GATT protocol that is part of Bluetooth Low Energy. So basically, it's CoAP over Bluetooth Low Energy. Comes from 2020, when also in IETF 109, I've described this briefly to the working group and proposed it for the experimental track. In the course of 2021, not 2001, I've worked more on transport indication, which provides a lot of background for CoAP over GATT, because CoAP over GATT would register a new CoAP scheme, and there is the there is this open item of finishing that, making something usable with respect to protocol negotiation before we register any additional schemes. Now, this in early 2022, some industry interest has sparked up on that topic, and there are now people from both ASA ABLOY and IETF that are interested in furthering the specification and using it, for example, in combination with the ACE framework. So they and I have started filling out some gaps in the specification, which I'll come to in the next slides. And here I'm giving the status update of this on this. So what has happened in the document already in the version that I've uploaded before the cutoff is that it is now more explicit in differentiating this from alternatives that are around. In particular, choosing to go directly over GATT versus choosing to go over the IPSP profile on BLE, which exists and is established, is something that is limited to a particular choice, or that is shaped by limitations of particular environments. So when you're operating a cell phone, you do not have the option to even reach the necessary components in the Bluetooth stack to implement 6LoWPAN over BLE or IPSP. You're limited to basically taking GATT. Everything else is not as easily accessible as GATT from an application implementation point of view. There is one alternative that is also being considered, that is the Golden Gate approach that Fitbit presented some time ago, which is taking the accessible components up to GATT and then building an IP transport on top of this. But given that in practice this would mean that applications are starting to implement an IP and an UDP stack, and given that this is introducing a lot of overhead, I think it is not the right approach for the particular use cases that we're looking at here. That is getting from your end user device into a CoAP-enabled device, even though they are not on the same kind of, even though they don't have a routed network between them, and even though you can't just join this BLE network from the phone. Things that are happening as part of that are ongoing and that are not part of the document yet are about fixing limitations. So the original draft was intentionally very limited. There were no concurrent requests. There was only one role described of who is the servant, who is the client. There were not even tokens in there because the original idea was that there are different characteristics in GATT, so maybe these could be exploited to not even send a token at all around. Some of these turned out to not work exactly that way, so these are being reshaped. Some of the assumptions didn't hold, and some changes are just necessary to, for example, get bidirectional transport. The reason we can't just take plain CoAP over UDP and pack it into GATT is that it has vastly different properties from the UDP layer that is underlying CoAP. So compared to that, for example, we have complete ordering. Reads and writes are never reordered by the network. But then again, the reliability this provides is highly asymmetric. So this needs this needs a few changes, but I won't go into details of those changes because they are essentially something that that is being hashed out with people that are experts in Bluetooth Low Energy and outside of the scope of this working group's expertise. What is very much inside the scope is how things would be addressed. So the natural choice here is to have a new scheme and put Bluetooth MAC addresses in there. The hard thing is that we don't always have these MAC addresses visible at all. For example, because different platforms has different takes on what it means to not to preserve the user's privacy. So in essence, we are down to the platform will provide some identifier, and that identifier might only be meaningful to a on that particular host. And while this sounds strange for URI, it's not completely unheard of because we are in the very same situation whenever we have linked local addresses. Their URI form also only makes sense on that particular host and is not usable across the network. But the bigger question this sparks is, when do we actually need those addresses? Because sure, if we had a MAC address, we might try to get some routing via proxies in there, but that's not what typically happens. What typically happens are two scenarios. One is that the device is sending a request out through the, in the typical case, the end user's phone up to some service, and in that case, the phone acts as a proxy, and the request uses forward proxying to some address that is not even core plus GATT, but something completely different, like core plus TCP, and translated by the proxy in the phone. And the address of the device never gets into the whole game. And the other scenario that we often see is that the device registers itself at some service that is operates like a resource directory. For example, on Lightweight M2M, this is what happens. And only when you start thinking about more niche use cases, like after having registered, still doing peer-to-peer contact, then you start to think about what scheme can be used there. I think that these considerations for what addresses we can use for the for CoBE and when we actually need them should shape the direction which transport communication is going. That is, that nodes whose local addresses are not particularly meaningful might not only want to use a particular endpoint identifier when registering at a resource directory, but start using whatever their more semantic identifier is in the first place and just offer proxying through these. And transport indication is a document that provides all the building blocks to make this this practically usable. But I think this should be not only part of the result of me applying the particular problem, the particular solutions to that problem, but part of a larger process in which we reevaluate how we do addressing in a non-traditional setup. Thanks, Carsten. That's a great keyword here. And I think it also highlights the troubles this is having, because this is not how we've been doing things before. But then again, maybe we just hit what we are doing in things like a proxying resource directory. Going forward with COAP over GATT, I'll be working on this on the details of how is this transported over the GATT side. But I'll need input from this working group as to how this would interact with addressing. Also to not only for this document, but also to further transport indication. And last but not least, this might be a candidate for a standard track document now, given the way people want to use it. And this too means that we should have more of the discussion on this here and not just working on this document alone. Thanks. Comments, questions? I think we're a bit over time, but if we can go 5 minutes over time, there might still be room for a question.
Yeah, probably going to close the room in a few minutes, not less. Carsten.
Yeah, I just wanted to say a +1, but I also wanted to create a local discontinuity in the space-time continuum, so we can continue talking for a couple more minutes. So a few people have to go. That's unfortunate, but yeah. So I use this name non-traditional addresses here just to point out that this may actually be the interesting question. How do we work in environments where we cannot make the same assumptions about addresses? Of course, NATs already provide one such environment, but we pretty much know how to manage those. But these addresses are weird, and we want to understand how to use them in places like directories and proxies, and so on. So yeah, let's do that.
Thank you.
And as mentioned in the chat, let's bring this to an interim meeting. Until then, it's good if people read the document and comment on the list, of course. We need that too. Okay, we are at the AUB, 5 minutes late. Karsten, do you still want to very quickly mention that item you had?
Yeah, so I looked at the core group proxy thing, and actually I had it on my to-do list in line 175, and I definitely will get to this, but maybe not next week. So yes, the idea is that Jaime and I have to come to an opinion on what we're going to do there next, but definitely this is a document that merits attention. So expect to hear from the chairs about that soon. The CoRPS plus JPY thing I wanted to mention in the ANIMA meeting, it turned out they want to use resource discovery for a resource that is not your grandfather's CoRPS resource, but they have a special tunneling protocol installed there. And our knee-jerk reaction to changing anything in the transport, of course, is to add a plus transport to the URI scheme. And we should check whether that is actually what we want to suggest to the ANIMA working group to handle this. Because right now, the resource type registration they are making is a little bit icky because they are advertising a resource that doesn't exist. And Marco, you wanted to say something about the interim schedule.
Right, the very last bit. We still have to confirm with the CBOR chairs, but we plan to resume with interim meetings for core at the end of August, on August 31. We'll confirm it to the list. And that's it. Any very final comments, remarks, anyone? If none, thank you for your time and extra time. Keep up the good work. Enjoy the rest of the week. Talk to you at the interims. Thank you all.
Thank you.
Bye-bye. I agree.